Am I on? Yay! Hello, everybody. Thank you for joining me. My name is Shel Styrioff, and I'm a Senior Program Manager with the Windows Fundamentals Ecosystem team. I'm here to talk to you all today about the Windows Performance Toolkit. In case you don't know, the Windows Performance Toolkit is a free resource that you can download online, and it's also available on your USB stick. So everything you'll see today, all the features and functionality that you're going to see in this hour, free, you can get through the toolkit. And we have a jam-packed hour, so I'm just going to get started. What we'll be discussing today, there's a number of performance discussions earlier today discussing the performance journey. We'll review that. We'll also define exactly what the Windows Performance Toolkit and what's included in it. We'll talk about what the iterative approach to performance analysis is, and then we'll be spending the majority of our time in demos. The objective of this hour is to familiarize you with the tools. Those tools are very rich. There's a lot of features and functionality within the tools. We will not be going deep on analysis methodologies. So there's a lot of resources online. There's also a number of sessions that were happening today as well as tomorrow that you can review to really go even deeper in analysis methodologies. We'll be talking primarily about the tools here, though. Where are we at in the performance journey? We had a discussion earlier today by Will about the performance journey, planning and architecting for performance. To be quite frank, building great apps starts at the beginning of when you're planning and when you're thinking about your app. Where we'll be discussing today is when you're at towards the end of the process, you say, I'm going to test, I need to measure, I need to understand why this scenario isn't performing the way I want it to be, and then how I do that analysis, how I improve that scenario. There are two tools that you can use for performance analysis. There's Visual Studio tools and then our toolkit, the Windows Performance Toolkit. I encourage you to also go look at what Visual Studio has available to you. There's a lot of great resources and a lot of great tools available within Visual Studio. So do check that out and make sure that you're familiar with those as well. With that, what is the Windows Performance Toolkit? Windows Performance Toolkit includes two primary applications, the Windows Performance Recorder and the Windows Performance Analyzer. So the Windows Performance Recorder, or WPR, is the tool that you'll use to capture the trace of the scenario that you want to understand and investigate. So what problem are you having? And you'll use Windows Performance Recorder to capture a trace for that problem. Once you have that trace that you want to investigate, you'll open that trace up in Windows Performance Analyzer and do that deep, in-depth analysis to understand what the root cause of your problem is. My colleague Lilithra discussed last hour about an iterative approach to performance analysis. So once you identify that problem, you're going to measure the scenario using WPR. That's where WPR fits in. You'll analyze within WPA, and you'll use WPA to determine what resource you're bound by, identify the UI thread, and understand how you're spending time. What is happening in your application that is causing the performance to be less than optimal? And then you'll modify your app and improve. Keep iterating. With that, we're going to go look at demos. So I'm going to switch over to Windows Performance Recorder. So this is what WPR looks like when it is first launched. At this point, I could click that Start button there and just begin capturing a trace. Before I do that, though, I'm going to show you some options that you have within WPR to further define what information you're going to capture. We have the first level triage. This recording profile is going to allow you to define exactly what you want in that trace. What type of information do you need to investigate your problem? First level triage is super basic information about the system and about what's happening on the system. You're going to want to always keep that enabled for any type of analysis that you're doing. We also have resource recording profiles for specific resource analysis. If you're investigating a CPU usage issue, file I/O issue, you can enable these recording profiles and get additional information about those. And we have scenario analysis recording profiles. What the scenario analysis recording profiles allow you to do is define a scenario that you want to investigate. And then we will capture all of the information you need for that entire scenario. Instead of requiring you to go enable different system-level resource profiles, you can just go enable this one particular profile, and you'll get all the data you need. And this is important to call out because down here, towards the bottom of the list, we have XAML and HTML profiles. Those are profiles that we have built and we'll be shipping with the product for you all as app developers to use. If you're a XAML app developer, you'll want to obviously enable the XAML recording profile. And if you're an HTML app developer, you want to enable that profile. And that will give you, again, all of that information you need about the framework and how your app is impacting the system through the framework. This will be critical for you to be able to understand the performance of your app on the system. We also have 2 logging modes. We have the logging to memory option and the logging to file option. Logging to file is great because it gives you a nice, complete trace of the scenario that you're looking at. Does cause file I/O. Okay, so if you're looking at a file I/O issue, you're obviously not going to want to log to file. Logging to memory helps you avoid that file I/O, but it is a circular buffer, which means that your trace can get cut off and wrapped. So depending on the scenario that you're trying to investigate, you'll want to make a decision about what logging mode you use for your trace capturing. Now, at this point, I'm going to go start trace. I'm going to show you my app. Drag this over here. There we go. This is our demo app that we have. There's 3 issues that we'll be discussing in today's demo. There's this page navigation issue. So you noticed when I navigated to that page, I'll do that again, you see this long delay before it tells me that it's done loading. That's a problem. I don't want that delay for my customers. I want my content to be there right away. I want it to be snappy. I want it to be fast. Also come over to the layout issue and notice that lag that happened before the content came to the screen. There was this delay before that content was rendered. I don't want that. I want my content there right away. And then we have the panning issue. So this stuff jumps, don't know what the deal is there. And if we were panning this, you would see some more delays and glitches. So to capture a trace for this, you'll notice that I'd already launched my application before I started capturing the trace. As a best practice, you want to capture a trace that's really focused on the scenario you want to investigate. You get a lot of great data through WPA, but you don't want data that you don't need, right? So really start the recording and then do the scenario that you want to investigate and then stop recording. Don't include spurious information in that trace. So I've launched my application because I have a great app launch experience. And then I'm going to switch over to the recorder. I'm going to start recording. Oh, excuse me. And then I'm going to come back over here. I'm going to go through my scenario. And then I would go back to the recorder and stop recording. At that point, I have all of the data that I need to begin my trace. I have all the information I need to go and analyze my trace. And I can then open up that trace in WPA. Now, the important call out that Will discussed in his session was that you want to capture a trace on a diversity of machines. Best machines to capture traces on to really optimize the scenario are WinRT machines. If you optimize on WinRT machines, the improvements that you make there will just come across all the other machines. So I captured this trace on a WinRT machine, and now I'm going to move that trace over to my demo box, to my dev box. WPA is a bit resource intensive, so moving it onto a bigger machine will be useful for you. At this point, this is what WPA looks like when I've opened up a brand new trace. You'll notice that there's this analysis tab over here. We'll talk a lot more about what the analysis tab will do for you in a moment. But there is this analysis tab here. And then we have the Graph Explorer. What we've done with the Graph Explorer is we've taken everything that we know about that particular resource, all of the data available to us in the trace for that resource, and put it into these logical groupings. So everything that we know about the CPU, for example, has been put into the computation category, and everything that we know about the disk has been put into the storage category. So everything that WPA has available to us is now put into these logical categories for you to kind of go through, dig in, and understand what's going on. You also notice that we have these squiggly thumbnail line things. We call these the KPIs, or key performance indicators. With the key performance indicators, we've taken everything we know about that particular subsystem, in this example, everything that we know about the CPU, and provided a rough, at-a-glance judgment about what we think you need to analyze. So through those peaks and valleys that you see there, you can get a rough understanding of what's happening on the CPU versus the disk and make some quick judgments about where you should start your analysis. As an example, when I look at this here, I see that I have a lot of activity going on in the CPU, particularly early on in the trace, and not so much happening here on the disk. There's these peaks up here at the end, but generally I'm seeing a lot more activity on the CPU. So I'm going to click on the CPU, drag that over into my analysis tab, and I'm actually going to switch this into graph mode real quick. And now I have the default CPU graph, which is, if I look at the title here, CPU usage and utilization by process. So what I'm looking at here is the utilization by process over time. So I'm seeing what processes are using CPU as a function of time. And you'll notice on the left of the graph, we have the series of processes that are being graphed. And we also have the legend. The legend allows me to identify which line maps to which process. So if I look at this, I can see this red line here maps to www.host.exe. I can also hover and get the tooltips and see which process that is being represented. Now I'm going to go over here and enable the table. And now I see what utilization by process looks like in aggregate for the entire duration of the trace. So while the graph is showing me what's happening over time, the table is showing me the in aggregate for the entire duration of that trace. This gets you to the heart and soul of WPA. The graph and table work together. They represent the same set of data, and you can navigate back and forth. For example, if I select this process here, now I've selected it in the table, and I see the highlighting in the graph, the shading in the graph of where this process is using CPU. Similarly, if I select a particular time range in the graph, I get shading in the table to show me which processes are using CPU during that particular time span that I selected. Similarly, or relatedly, you'll notice that we have different levels of shading in the table. So idle is actually shaded much more darkly than the other items. And then we have explorer.exe that's shaded a bit more darkly than the others. That indicates to you that idle is happening most frequently during that particular time span. And then the next thing that's happening is the explorer.exe process. So we use the shading to indicate to you quickly and easily what is happening more frequently during that time span versus other things. Now, at this point, I'm going to start my analysis by understanding what resource I'm bound by. Looking at this, I think I'm CPU bound, as we discussed before. I see a lot of activity happening on the CPU. First thing I'm going to do is make sure that there's not things that are happening here that aren't expected. Are there other things that are happening on the system that I'm not expecting that might be impacting my app's performance? And looking at this, I see the WWA host. WWA host is the framework in which my app is running. Because this is an HTML app, it's running within the WWA framework. OK, so that's my application. Got that. Then I see DWM. As Lithra had discussed last hour, and perhaps you heard in other sessions that you attended, DWM, the Desktop Windows Manager, will do work on your behalf to get your content to the screen. So it takes, once all of the pixels have been defined by your application, DWM will take those pixels and put them onto the screen for you. So when I look at this in WPA, I can say, DWM is probably really doing work on behalf of my application. And so anything that I see here that DWM is doing is really be attributed to my application as well. So that's expected. It's normal. DWM is doing work for me. We can make a similar judgment about the system. System is often going to be doing work on your behalf as well. So when I look at this, I can say that's expected as well. There's nothing here that's not expected. At that point, I can then drill into my application, where it says WWA host, and start looking deep at what's going on within my application. Everything else looks like it's expected. I'm not seeing anything that does not look normal. So I'm going to right-click on that and filter to selection. Now, you'll notice that I did that through the graph. The table was also updated to filter to my application. So it got rid of all that other information that I didn't feel like I needed to look at and really brought me down both in the graph and the table to show me just information that was particular to my app or specific to my app. I'm going to expand here. And then I'm going to select the time range here for us to get started. So at the beginning here is when we were doing the page navigation. And that's the scenario that we're going to look at first. So I'm going to select that time range. And I'm going to right-click, and I'm going to say Zoom. Now I've gotten rid of all the information that is not specific to the time range for the scenario that I want to look at by right-clicking and zooming into that time range. When I did that, the graph was updated with the same time interval. And the table was updated with the information from that time interval. So any information in the table that was not specific to that time range was also filtered out. The other thing I want to highlight to you, which we'll see at work a little bit later here, is the ability to visualize across resources. So I just drug over the default storage graph here. And I can see that automatically this graph was trimmed to show the same time range that my CPU graph was showing. So even across resources, I've been able to get that quick visualization of that same time range. Similarly, if I were to highlight this particular range in the disk, so I highlighted that time span in the disk graph, I get that highlighting reflected in the CPU graph as well, so that selection is maintained across resources. You'll see this at work a lot more later, but I wanted to highlight that and show that to you as an introduction to that. So at this point, what have we done? We've said there's nothing that looks odd happening on the machine. It really does look like there's something going on within my app. We think we're CPU bound. Now we need to understand what the UI thread is doing. What's the UI thread doing that's taking time on the system? At this point, we'll be drilling into the HTML UI thread, but these methodologies do apply to XAML, and all the views are also available to you as a XAML app developer. So everything we'll look at will apply to you as well. First thing to do is to select a time range where you see a consistent pattern. So here I see a very consistent pattern where I'm having a very consistent trend, and I'm going to right-click and zoom into that particular range specifically. When I look at this, I see that I'm pretty consistently having CPU utilization around 25%. That's super interesting to me because I captured this trace on a quad-core machine. If I'm at 25%, that means I'm using basically the entirety of one core. So I'm feeling more confident at this point that I am, in fact, CPU bound. And I'm going to come up to the graph title then and switch over to another graph type. We call these presets. What the presets do is they give you a completely different data configuration for the data that you're looking at. So all of the data that I have here, I'm going to just get a completely new pivot on it, and I'm going to switch down here to utilization by process and thread. Now I've got my process name and my thread ID has come in here. When I look at this, I see this thread ID 8624. That is probably my UI thread. And I say that is probably my UI thread based on the amount of work that's happening on that thread. I see about, 704 or so amount of utilization happening there. So that's probably my UI thread. But through WPA, I don't have to guess. I'm going to come up to the column header, and I'm going to right-click, and I'm going to come down here and add thread activity tag. Or sorry, thread activity name. There we go. At this point, it would be beneficial for me to explain to you the taxonomy that we use in WPA for the tables. We have the gold bar here and the blue bar here. Now, the way we use the gold bar is anything to the left of the gold bar allows you to define how you're going to group data. So you can drag your columns over to the left of the gold bar and define different groupings of that data. The right of the gold bar allows you to define what's going to be graphed in the graph. So I'm going to take the thread name column, and I'm going to drag it over. And I'm going to expand this a bit so you can read the full name. And I see that this 8624 thread ID is, in fact, the HTML UI thread. So I found the HTML UI thread. What is that UI thread doing? at this point, I'm going to switch over to a different CPU usage graph. And I'm going to see a different view of CPU by expanding this little, what is that, triangle there. And I'm going to come down to the CPU usage attributed graph. This collection of graphs here allows me to get different visualizations of the data available to you for the CPU. So I drag over that CPU usage attributed graph, and I'm going to move that up just to give us more pixels. Handy thing to remove column names is right-click and disable show column names. That way you get a little bit more pixels on the screen for information that you do need. And then I'm going to modify this view. Now, I could do the right-click on column header thing and drag the columns around again, but I have some significant updates that I want to make to this view because I want to see my process, and then I want to see that thread name, and then I want to filter by that and only see the activity that's happening in those particular information there. So I'm going to go to the view editor. This is the view editor. What the view editor does is it allows you to define a little bit easier what columns you want to see, what order you want to see them in. This is a bit easier than dragging the columns back and forth, particularly if you're making substantive updates to your view. So as I said, I wanted to see process first because I want to look just at the WWA host. I'm going to enable thread name because I want to look at things that are only from the HTML UI thread. I'm going to move the thread ID up so that you can see that thread ID is maintained. I'm going to disable that to give us a little bit more space on the screen and hit OK. At this point, I will right-click on WWA host and filter to selection. An important call out here is when you drag graphs over from Graph Explorer, your filtering to a specific process is not maintained. So you will need to do that refiltering. So I just refiltered again to my process, and I'm going to expand that. And here I have my thread name, HTML UI thread, and I want to see what the HTML UI thread is doing, so I'm going to filter to that. And I'm going to give myself more space. And I'm going to expand here. And I don't have symbols loaded. So many of you have probably used symbols for various things. There is a way to configure symbols in WPA and get symbols loaded for your application. You can come up here to Trace, Configure Symbols Path. And here you would put in a period. And you will be able to define what your symbols path is down here. So you can build that local symbols path, point to your local symbols path. You can also, through the first symbols path here, you can point to the external symbols path and get the Microsoft symbols. So there's a lot of great resources at the end with documentation to point you to all of that. But I wanted to call out you can configure symbols, you can get your own symbols in here, and there's a way to visualize that if you need it. So now I've seen this bar here, so it tells me symbols have finished loading. Excellent. And I'm just going to drag back over the CPU usage attributed graph. I'm going to update that view again. Process name, thread name, thread ID, ba-dum, OK. And I'm going to filter to my UI thread. Expand. So at this point, I can see visually a bit more about what's happening and what utilization looks like within this particular UI thread. So this is a handy way to get some understanding of what's going on here. Now, let's say that I really like this view. I can also come up here to the view editor and save that view and reuse it for another graph. So I'll come up here, and I could just click Manage and give this view a new name. But instead, I'm going to actually go to Advanced, and I'm going to define the WWA host, because I want to keep that filtering of things that are specific to my framework. So I'll come down here, and I'll go to Process, Contains, WWA host, and click OK. And the reason I want to do this is because even if you save a view that you like to reuse later, the filtering to that process is not maintained unless you define it through that Advanced tab. So now I can come in here, say manage my presets, save, OK. Now you'll notice that my view here was updated for that particular, with that new graph name, or that new preset name. And if I come over here to the CPU usage sampled collection, I can see down here is the preset that I just created. So that's a handy way to take views that you like and reuse them later. I can also take this collection of tabs and update those. So here I right-clicked on the tab name, and we'll say my favorite tab, and I hit caps, but that's OK. So now I right-clicked and I've renamed that tab, and then I can actually save this particular tab view through profiles. So if I come up to profiles and I go export, say here, my profile. Now what that will do is it will take all of the data that you see on this screen, and then I can apply it to any other trace. So it's taken all of the trace-specific information, gotten rid of that, and now you can take that information about the graph and table configurations and apply it to a new trace. So if I come over to this new trace, which you'll see is HTML app 02, whereas this one is HTML app 01, I'll go to Profile, Apply, Browse, My Profile, open. And now here are my two graph table configurations that I just had. Here's my preset that I had created. Here's my utilization table that I had added. So that's a really handy way to take views that you like and reuse them for future analysis. You can also save, if you have a specific view for a specific trace, you can also save that by going to the File Export Session option. Now I'll save everything, including the trace, but that's not reusable for other traces. All of this that we've discussed so far assumes that you're building your view from the ground up. Let's see what happens when I use some default views from Microsoft. What we've done is we've taken some of the favorite views that we use internally for modern app analysis and created a profile for you all to use in your analysis. And I can get to that by going to Profiles, Apply, Browse Catalog. I'm going to select the HTML, but you'll also notice that there is a XAML profile available to XAML app developers. And I'll click Open. And now I get a bunch of great, useful data for me configured right away out of the box without requiring me to go through the configurations to make those specific views. First thing to notice in the Microsoft-defined profile is the Windows in Focus graph. The Windows in Focus graph allows you to visualize what process is in focus, what things are happening as a function of time. So when I look at this, I see at the beginning of the graph WPR. And when that makes sense because that's what I use to capture my trace. So that's what happens first. Then I see explore.exe, and I see two separate sections of that. Based on my understanding of the OS, I can infer that this is when I switched over to the Start menu to go to my app. And then this green box here is when I saw my splash screen. And then the next item is the WWA host. What's handy about this is now I can select my process there, the WWA host, and right-click and zoom. Now I've gotten rid of that additional information in the trace that doesn't have any activity based on my application. So I'm looking only at the information related to when my application was in focus. At this point, we're going to look at a different portion of the trace. We're going to look at when we were having that layout issue. So when those set of icons came in very slowly. So I'm going to select this particular time range to look at that. A right-click zoom. Looking at this and thinking back to our iterative approach to performance analysis, I'm going to look down the list of resources here. Here I have my DWM frame details. As you've probably heard at some point today, if you're interested in performance analysis, is DWM, again, is the thing that puts those pixels onto the screen. And a really good experience is when you have 60 frames per second. So this particular preset, which is the DWM frame rate, shows me how many frames I'm having per second. And I can see here when I'm doing my 2 sets of layout that I do consistently have 60 frames per second. Thinking back to that iterative approach to performance analysis then, and thinking about what resource I'm bound by, I'm probably not bound by DWM GPU work here. I can also see down here in the GPU utilization that I have some peaks and valleys happening, but I don't see a consistent 100% utilization on those peaks. So those peaks aren't spiking to 100%. This is a healthy GPU utilization view. We'll see an unhealthy view a bit later. But this is very healthy where I'm not seeing very high spikes. I'm seeing the low dips. I'm going to switch this view over to a different chart type. This is a really handy way to change the view to get a different visualization. So right now we have it in stacked lines. I'm just going to move over to lines. And now I can see what the WWA host is doing. And when I select the WWA host and look at the red line here, I see I'm at pretty much 100% CPU utilization for the entire scenario. What resource am I bound by? Again, this looks like a CPU usage issue. Next step is to zoom in even deeper to a particular time range where you see a consistent pattern. So I'm going to zoom in here. And again, looking at the frame rate, I see 60 frames per second. I see this very healthy GPU usage graph, and I see 100% CPU utilization. So I'm going to switch over to the frame analysis tab, which is the next tab in the profile that we shared with you. Because at this point, I feel like I am CPU bound, and I want to understand what is happening within the UI thread to get a better feel of what I need to improve. So when I come over here, I'm going to just jump down here. We'll talk about some of these other graphs a bit later. I'm going to right-click again, remove the column names. Now, an important thing to call out is when you navigate between tabs, your zooming to a time range is not maintained. So I need to go back and pick up the time range that I had zoomed into, which was about 14.25 to 14.75. So I'm going to come over here, select something around here, and zoom in. And I'll actually zoom in a bit further to this section. Okay. So that's about the same time range that I was in before. And when I come down to the CPU usage attributed graph, I have this preset, which was given to me as part of the profile. So this is part of the profile that we shipped to you for Modern App Analysis, which is the HTML UI thread CPU breakdown. I also want to call out, again, for XAML developers, we have the XAML version right here for you, so you can switch that over to that preset. When I look at this, I get these colored bars here, and I can map those to the work that is happening within the UI framework. So I see here I have a lot of purple and a lot of red. That's a lot of layout and a lot of formatting work. This is really interesting to me because then I can go drill in to the other graphs that are available and understand what layout and what formatting work is happening. So I'm going to scroll down further to the HTML frame details graph. What this graph will do, if I switch over to the work breakdown preset, is show me exactly what's happening within the frame. So I can see here that I've got 2 frames. I'm going to drill in. I can see layout. And if I drill in further, I see formatting here. An important call out here is if you're having a layout formatting issue, formatting will always be contained within the layout. And that's because the UI thread will go, hey, do I have formatting work to do? Yes, you do. OK, I'm going to go do that first, and then I'll get back to my layout work. So looking at this, you'll always see the formatting within layout. If you don't have any formatting that needs to happen for that particular frame, you won't see formatting there. Now I'm going to drill in to the formatting. And if I drill in and give us a little bit more space here, let's move this over and move this over. There we go. and move that way. Now I can actually see the divs that are being formatted. Now I have really great, rich information about what I need to go improve within my app to make this experience more performant. All of this assumes that I'm having a fluid problem, or fast problem, excuse me. What if I'm having a fluid problem? What if things like panning aren't going as well? What if my animations are glitchy? What if I'm having something that really looks like a fluid experience issue? I'm going to zoom out, and we'll go take a look at how I can use these graphs for a fluid problem. So we'll stay over here. So down here is where I was doing that panning. And when I look at this, first thing to notice again is the DWM frame rate. I'm not seeing it 60% across, 60 frames per second across a significant amount of this particular scenario. I have a little bit happening here at the beginning, a little bit happening here at the end, but a majority of this looks like it's closer to 20 or 30 frames per second. That's probably why I'm seeing the glitchiness happening in that experience. So if I pick a time span where I'm having a more consistent usage, so I'm going to select this range here and zoom in, I can get an even better view of what's happening. So really consistently, it does not look like I'm hitting 60 frames per second. I can see what my GPU utilization looks like. You'll notice that these GPU spikes are more tightly grouped than the last set that we looked at, and they're consistently hitting 100%. This is a more of an unhealthy view. I can get an even better visualization of that by zooming in further. I'm going to zoom in to any one of these ranges here, and I'm going to select a group of those spikes. Zoom. So looking at this, up here, we have the vsyncs. If you have heard from Lilithra's talk, the vsyncs are the periods in time in which we take the information from DWM and actually put it on the screen. So in order to have a fluid experience, glitch-free experience, you need to have all of your GPU and CPU work done in time for that vsync. You want to see your GPU and your CPU work be at completely 0% when you hit that vsync. And that means that your application has done everything that it needs to do, and all of the data you wanted to be on the screen at that time is there. When I look at this, I'm actually going to show you one other quick trick. I've selected the vsync here in the graph. I can right-click and say Highlight Selection, and that will draw the vsync, the green vsync lines down the other resources. Excuse me. So if I zoom in here and look at this, I can see here's, actually, sorry, I wanted to zoom out a little bit. Let me zoom in on this one. There we go. I can see here's a vsync here, here's a vsync here, here's a vsync here, vsync. You'll notice when I look at this, I'm having this work here happening after the vsync. That's a glitch. That means that I did not have the information ready and available for the system to put it to screen on the vsync. And I see that that's a pretty consistent pattern, so I'm having pretty consistent glitchiness across this scenario. What a healthy pattern would look like is your GPU utilization would drop off to 0 right before that vsync, and then spike up again right after the vsync. Another important call out, you might hear people talking about every 16 milliseconds. In order to reach 60 frames per second, your refresh rate on your screen is every 16 milliseconds. So you have 16 milliseconds to get all of that GPU, CPU work done and get that stuff available for the vsync. Looking at this particular scenario then, I'm pretty confident that we are GPU bound. We're having a graphics issue. To understand better what is happening, you can drill into the graphs more like we did before, but really at this point, based on our understanding of how fluid works, we can say, I need to reduce overdraw. I need to not ask so much of the GPU to get this information drawn to screen. If you have a bunch of layers with a bunch of pixels on them that are overlapping, remove those. Reduce that information there. You also can be a little bit easier on the CPU to improve your fluid experiences by reducing the complexity of viewer UI. So if you see a GPU issue, really the first step is reduce overdraw. Second step, reduce the complexity of your UI. Those two actions in combination will get you a better, more fluid experience right off the bat. Now, at this point, everything assumes that I'm looking at a single trace scenario. What if I have a great experience and it regresses? So I had a fabulous launch experience. I was super happy with my launch experience. And then something happened. I changed my code, and my launch experience started to suck. We have what we call comparative analysis for you. So I'm going to switch over to this view here. At this point, you'll notice that I have two graphs. Oops, excuse me. Oops. I have two graphs open. And you can tell that by looking down here at the Graph Explorer. I have graph number 1, which is indicated by the number 1 and the blue. And I have Graph Explorer number 2, which is indicated by the red line and the number 2. If I hover on those, I can see which trace maps to that Graph Explorer. So if I hover on the first one, I can see that that is my great launch experience right here. And if I hovered on the second one, I would see that that is my bad launch experience. If I drag over the default CPU usage graph to an analysis tab, you'll notice that I get, again, the number 1 and the blue. So what that tells me is all of the information in this analysis tab is coming from that first trace, that great launch experience. That's a really easy way to visualize or understand what data you're looking at and map it back to which trace you're looking at. I can also, as a quick example, create another analysis tab, drag over another computation graph, and here I see that I get the number 2 and the red. Now, again, these are single analysis tabs. I want to compare. So I'm going to come up to Window and select New Comparative Analysis right here. What this will do is this will create another tab for me where I can define what my baseline trace is and what my comparative trace is. So what was my good experience? What's that baseline experience? And then what's my bad experience? So I'm going to say my great launch is my good experience and my bad launch is my bad experience, and I'm going to click OK. Now I have a new tab called Comparative Analysis tab. And you'll notice that I have the number 1 and the 2 again with the blue and the red indicators. What that tells me is that this is a comparative analysis where the trace number 1, the blue trace, is my baseline, and trace number 2, the red trace, is my comparison. Now I'm going to drag over a graph, and I'm going to show you guys another graph that we have, which is called the Regions of Interest graph. I'm going to drag that over. And I'm going to switch this to Thread Activities and expand. What the Regions of Interest graph allows you to do is define specific events within your application, okay? And then you can provide a regions XML and get that rich information with those additional events from your app visualized in WPA. I brushed over that very quickly. There's a lot of resources online that will help you with that. But this is a really handy way to visualize, get information that's useful to you brought up into WPA through the regions of interest. And for my app, my launch experience was not doing as well, so I put a couple of events into my launch experience. I put an event in for the work that was happening in HTML, and then I put an event in for the app activation work. OK, great. So when I look at the table of this table here is a comparative analysis table. What that means is it's taken, in the table, it's taken all of the data from trace number 2 and subtracted the data from trace number 1. It's showing me the delta between traces number 1 and trace number 2. So if I look at this, I can see that the delta between the two was about 9 seconds here. So my experience in the launch has regressed by 9 seconds. When I expand my app and look at what's going on with those specific events that I created, I can see that I've got about 3-ish minutes happening here. There we go. I got about 4-ish minutes happening here and about 6-ish minutes happening here. So, okay, I now can see where the work is happening. It's pretty consistently just degraded between the two experiences. What I could do then is go over to my computation graph and start drilling into what the deltas are between trace number 1 and trace number 2. Now, an important call out, you'll notice I switched this into table mode. In comparative analysis, tables are always diffed. Graphs are never diffed. Okay? So let's say that I understand now I have an issue within the launch experience, and I'm going to trim my time range to only when we were looking at the launch experience, and I'm going to move this up. Now I want to update my utilization graph to look at data from trace number 1 for that launch experience and look at data from trace number 2 for that launch experience, right? You guys with me? Data from trace number 1 for the launch experience compared to data from trace number 2 for launch experience. When I look at this CPU usage graph, I can see that I am looking at data from trace number 1. And I know that based on the little toggle switch down here, where this little button is on the number 1 side. Okay? So if I come back up here, I can select a time range in trace number 1, zoom in. So now I've got the 3 seconds to about 7.5 seconds in trace number 1. And then I can toggle that over to trace number 2, select either the same time range or a completely different time range, zoom in. And now the table has been updated to show me data specific to that time range for trace number 1 and the time range I selected for trace number 2. This is a really, really handy way to start to understand your regressions. The comparative analysis is built into the underlying framework, so any graph and table that you drag over, you can use comparative analysis for. You can filter out the data that you want, just as I showed you here. The other interesting call out here is that you can do comparative analysis within the same trace. So if I wanted to compare a time span from trace number 1 to a different time span from trace number 1, I can do that within the comparative analysis view. So that's a pretty comprehensive view of what we have available to you within WPA. There were some great talks earlier that were talking about the performance analysis and app performance specifically. You can review these back on Channel 9 again. You can also check out some related talks looking at Visual Studio tools, looking at how you can develop high-performance websites. We have some resources online. Again, this is a free SDK. You can download it from that aka.ms WAC download SDK. You can also get it on your USB stick. We have a number of MSDN articles. We have a whole collection of technical documentation. This is a technical tool. There's a lot of documentation out there to help you. And that's it. So we've got about 10 minutes, so I can take a few questions at this point. And I do ask that you bring questions over to the microphone so that everybody can hear them. And the folks across the room that are in the overflow room, you can come over to this room to ask your questions. Yeah, yes. Do you mind coming up to the mic, sir?
We use this tool quite a bit, and it's an excellent tool, complement to your team.
Thank you.
One thing that I find that could be very useful, and I didn't see in the demo, I don't know if it exists, is an ability to turn the recorder from within our code. Let's say that we know that specifically we are in the initialization routine, say start at the beginning of initialization routines, stop at the end, and just have that capture. Otherwise,
Correct.
You end up with huge, huge logs that are not always.
Yeah, absolutely. So that's a great point. That goes back to what we discussed about best practices. Capture a trace only for the scenario that you want to investigate. WPR is completely enableable via command line. So what I showed today was the UI version. You can, everything that you saw today, there are switches available via command line for you to define. So you can do all of that via command line, define the profile, and use that within your automation.
That's not what I meant.
Oh, I'm sorry.
Writing native code. It's some call.
Oh, I see. Yeah. Yeah. Right. Yep. Right. Yeah. Thank you for the feedback. Yes.
My question is, how would you use this tool for threading issues? Like you have a lot of background threads, and now you have some kind of contention.
Right.
How would you use this tool to dig into that?
Yeah, so it's completely possible. We have we have all the thread ID available to you. You can look at the other resources to see what those are. We actually started this tool not for modern app developers. We started using it internally for these types of issues. So the one thing I will call out is that memory analysis for modern apps specifically is better through Visual Studio. So if you're having specific memory issues, you'll want to go to Visual Studio for that and look at that. But everything that you saw here around fluid experiences like GPU usage and whatnot, you'll need to use WPA for that. Yes, sir.
Can you load symbols from a C++ app, like a PDB file,
Yeah.
have all the function calls and whatnot show up in there?
Yep.
Okay.
So take a look at our documentation online.
Do these tools also work for WPF apps?
Yes.
Perfect.
Thanks for the talk. Any way to use it in automation test scenario where we can run automation overnight and it will flag whatever issues were discovered? Because this is pretty much a manual process right now.
Yeah. So you can capture the trace automatically via the command line option of WPR. Automated analysis is not something that we've shipped so much. We do have what is called the exporter, which we are shipping this release, which we will have detailed documentation on. What the exporter will do is it will allow you to define a profile that you want. So what graphs, what tables do you want to look at? And then you can export that data out of WPA into a flat CSV type file, and you can write a script to analyze that. So the automated capabilities are coming. They're not fully integrated into WPA per se, but all the views that you see in WPA, you can get that data back out through the exporter and then do whatever type of automated analysis on top of that you want.
Yeah, because it would be great to catch regressions in nightly builds.
Yes, absolutely. And that is actually why we shipped the exporter. Our internal performance team wanted that, and we said, wow, this will be great for all of y'all as well.
Okay, thank you.
Quick question, can you extend this to add maybe hardware-specific counters like GPU counters or CPU counters for apps that, GPU bound, you want to do an in-depth analysis in a certain area? It might be beneficial if you can get vendor-specific hardware counters like,
Yeah, because that's something we would need to go back to the hardware vendors for.
If you can define an API, maybe you can have, because NVIDIA API, and they always export out these counters and they have tools.
Absolutely,
so, is there a mechanism that you have in place?
So we don't have a mechanism for them to do plug-in. What we do have is the generic events graph. So if you enable information that we would get from a specific hardware, it would show up in the generic events graph. So if they've done something, you can visualize that through generic events, which is available under the system activities. But we don't have like if you had a piece of hardware that you were working on and you wanted to get specific events for your hardware into WPA, we wouldn't be able to do that at this point.
Cool. Thank you.
Can you just give more general view on production debugging story? This tool, debug diag. So how those tools fit together in production debugging?
Tell me more.
Well, there are more tools like debug diag, dump analysis. So I'm just trying to understand generally production debugging story. So I have production performance problem.
Right.
So how this tool complement other tools? How they
Yeah.
fit together?
So WPA, there's a lot of functionality within WPA, as you got an introduction to here. It's really great at visualizing across resources. I don't know about all of the tools out there. With Visual Studio, though, there are scenarios, particularly like memory analysis, where you'll be able to do more within Visual Studio than you will within WPA.
Yeah, this section is actually for the performance tool for application. So does this tool can be used to performance optimization for user mode driver or even kernel mode driver?
Yes. Yeah, so this tool started, what we've done this release has been to support modern app developers. But this tool started internally for doing performance at kernel level and driver level, whatnot, for our teams. And we work actively with partners to get them onboarded to this tool so they can use it for driver analysis, for example. So this tool is not, what we showed today based on the audience that we're sharing with, are the modern app analysis features and capabilities. All of the same stuff that you've seen here can apply to other subsystems.
Including the kernel mode driver?
Yes, including kernel mode driver.
Thank you very much.
Yeah.
Thank you.
Any other questions that we can go with? Yes, sir.
So will the tool, the log, does it actually capture like any perfmon counter or?
Perfmon counters. I don't know.
Okay.
I'm sorry, I don't know that one. Yeah. I don't know what provider that would be that you would need to enable to get that to show up. What I will say is that you can create custom profiles for WPR, custom recording profiles. And so if you were to do like an MSDN search, found the perfmon provider, then you could create a profile and then add that to WPR, and then we would get that information. As long as they have to kind of register themselves as a provider. So if they've registered themselves as a provider, and you tell us, hey, go get information from that provider, then we'll do that.
Okay.
But I don't know if they're registered as a provider. That's why I'm not sure.
Okay.
Sorry.
Thanks.
Yes, sir.
Is this tool available in Windows 7 or?
Yeah. Yes, this is available for Windows 7, Windows 8, Windows 8.1.
Thank you.
Any other questions? Cool. Thank you all. Go make great performant apps.